What is a model? What is modelling? If you've heard people speak at conferences about testing or read a book on testing, you'll see quite a lot of attention paid to models. Models are at the core of testing. Now, what you also know is, if you've any experience of testing on the behalf of stakeholders, is you have to understand their different perspectives, whether they are a user or a developer or an architect. Now, this notion of different perspectives means that it can be troublesome sometimes to try and get to the bottom of why they see things differently than we do. But models help. Now, people being people always have their own viewpoints. They have their own mental models, and those mental models represent their understanding, their perception, their perspective, if you like. Now, because of that, and people don't share their mental models in any sophisticated way usually, we have to kind of draw this information out of people's heads. And the obvious way to do that is to try and sketch out some kind of shared understanding, a shared model, to understand their situation from their perspective better. So what we do is, shareholders will have different mental models of their system, and their mental models will cover things like the functionality and quality, whatever that means, usability, risk, performance, and so on. And if you like, all these perspectives, they are visions or perspectives through a different lens, because those individuals have a different experience, different knowledge, different intuition and perspective, if you like. And so in order for us to have a shared understanding, that is, so we understand what they want from the system from their perspective, we have to have some kind of shared model to pick up on the nuanced ideas that they're trying to share with us, and also to get consensus. So we can have, if we have a shared model, we can discuss the challenge we've got in front of us together, understanding each other's point of view, and also come up with consensus. So this challenge of understanding what's in other people's heads is simplified if we can only get together a shared model. Now, what is a model? Well, a model helps us to define the essential aspects that are of interest to us, of importance to us. It helps us to define the scope of the problem, if you like, and where the boundaries are, what's in scope, what's out of scope, that kind of idea. Now, I want to just look at models from one kind of viewpoint, from the idea of looking at a system, a large system, as a kind of a hierarchy, or if you like, layers of an onion, which is the same kind of thing really. If you turn it inside out, it becomes a hierarchy. Now, the system we're looking at could be something like an electric toothbrush, or it could be an airport. Now, of course, in order to understand the workings of an airport and every aspect of it, the model would be incredibly complex, because the subject matter is incredibly complex. But by the same token, an electric toothbrush is not a simple system to test if we're looking at testing. Now, at the lowest level, the components of our system might be, in terms of software, a class, method, or it could be the entire business process. The business unit itself, the organisation, is a system in its own right. And so what systems thinking does, and what we do as a systems thinker, referring back to the video I did last week, we look and break down complex systems into components. And once we understand what a component is, we also need to understand the relationship that component has with the other components, which might be components or systems or huge systems of systems. So our vision of what our overall system is, it could be something like a simple piece of code, although code is never simple, or it could be an enormous system of systems. Now I want to just talk about how we might use this system of systems, some kind of architecture or some visualization, and the like the spinning wheels that kind of make me a little bit dizzy sometimes, represent systems that are connected in a system of systems. This might be the whole landscape of systems for a large organization. So one way of looking at systems that are in scope, let's say, is we might choose these three inside the red dotted line because they share common functionality. They might make use of the same web services, let's say, or they might share a database, or they share functionality or some aspect that is common to all three. Now, another way of selecting components or subsystems from this system of systems would be, well, let's look at all the components that are involved in a single user journey. And so the red dotted arrows reflect the 4 systems that are in scope, perhaps for some aspect of user acceptance or end-to-end testing, maybe. A third idea might be, well, let's look at the systems of record that share maybe the database or maybe some common pieces of data and see how they interact. And that might be what's in scope for us as testers. This idea of scoping is critical to what we do, is that we need to understand what is in scope for us. We need to also demonstrate and show and share what we believe is the scope with our stakeholders and agree that scope with them. So models help us to do that. Now these models might be models that have been given to us and are available as a document, let's say. But they might also be models that we have to create as testers to illustrate what we're talking about and to make the stakeholders aware of how we think about their system and get their input to make sure that our model reflects in some way, some sensible, meaningful way, their vision for the system as well. So what we do when we set scope is, one way of looking at it would be to say, well, let's select features that are used in a path through a business process, or features that share a common aspect, or features that depend on a particular infrastructure element, maybe some web services, who knows, and so on. But if you like, doing this with text may get us some way to our goal, but very often a visualization is much more useful because people like pictures, it's needless to say. Now, one thing to bear in mind is when we define our system and our model, and we select items in scope, let's say they are subsystems, as I've got in this diagram, we deselect or ignore other items. Now, by so doing, we are making a conscious decision to exclude things that are outside that scope from our activity. Like, we're not going to test them. We're not going to exercise them in our testing, let's say. Now, we need to be careful that by so doing, if we exclude certain aspects, are we making the model, are we corrupting it in some way? Are we excluding things that are critically important? Are we oversimplifying? Einstein was allegedly quoted as saying everything should be made as simple as possible, but no simpler. It's that idea that if we oversimplify the situation with our vision, our visual model, if you like, are we excluding stuff that's really critically important? We need to be really careful about that. Now, I want to just show a few examples of the kind of models, and there's an infinite range of types of model that we could talk about. But I just want to give a couple of illustrations to show that the range of models is very broad. We're not limited to architectural diagrams from our systems architects, for example. So one might be a sequence diagram. And a sequence diagram, for example, shows how components, in this case, how components collaborate to achieve some goal. They send messages between each other, perform functions, and arrive at some endpoint which delivers some functionality, probably to an end user. a class diagram or an object model. It could be hand-drawn, like this one. It doesn't have to be created using sophisticated tools or technology. But a class diagram gives us an understanding of the relationships in terms of the functionality, but also the data that each object makes use of. A common model is a state transition diagram, or sometimes called a state model. And these are the states and the transitions between states that reflect the behaviour of our system under test. Now, another common model is the business process that's given to us as this is the process that the system you're testing has to support. So of course we have to see whether the system will support that business process, and we usually do that by tracing paths through the model like that. We trace paths, and these become test cases or test procedures, if you like, that give us this end-to-end kind of concept of using the system in the context of the business process it's meant to support. If you like, what we're doing is integration testing of a system, and that it integrates with the business process. So integration goes right up to the top of the kind of agenda in that respect. Now, very quickly, I want to show some characteristics of models. This is not comprehensive, but essentially what models do is they simplify complexity. They help us to make sense of complex situations and systems that we deal with in software and organizations are always complex. So we typically are making models all the time. They focus on the important stuff and they exclude the rest. So they help us to understand scope. Now, critically, if we're talking to stakeholders, our models, whether they produce models that we reuse and they share with us, or whether we have to create a model and share it with the stakeholders to explain our thinking, they've got to be meaningful to stakeholders. So if our stakeholders are users, they're going to want to look at the business process and business activities and obviously features and functionality within the system through the user interface, perhaps. If our stakeholders are developers, we might take a much more technically oriented view and be looking at paths through software and interfaces and so on and so on. Our models have to be meaningful to our stakeholders. They help us to set scope, and by so doing, they also help us to set some form of coverage target, which is critical to explaining how much testing we're going to do, but also to set a limit on the testing we will do. Some kind of objective goal, if you like, in terms of the quantity of testing we're going to do. Mostly our models are visual. It's really helpful for people to look at pictures and share models in the form of graphical designs, if you like. But they're not always. There can be checklists as well. Now, in some respects, all models are heuristics. They're all imprecise. They're all abstractions, and they lose information when we abstract complexity to something simpler. We lose detail, don't we? But clearly, some models are more complex than others. So a simple model might be a heuristic, a checklist of test cases that we apply to standard numeric fields. But another heuristic checklist might be a risk register or a failure mode register. And although risk-based testing is a mature and relatively sophisticated approach compared to just hacking away, let's say, it's heuristic in that it's not perfect. It's never completed in some respects. So whenever you have a list of risks, there's always an opportunity to add another one. So it's never really finished in that respect. So we have to be careful about models that are heuristic and, if you like, informal in this way. And risk registers, simple checklists are always, I would say, informal. Useful, but informal. Now, a chap called George Box, a statistician, was talking about economic models. And he said this, which is a very famous statement about what we're talking about here. Is all models are wrong, but some are useful. So all models eliminate or reduce the content of a complex system to a relatively simple model, an understandable model. Now, those models can be useful, but they're always wrong. And also, not all models are useful for all things. So we have to take a little care with this aspect of it. Finally, I want to say that the reason models are important is models are at the heart of test design. And in the next 2 or 3 videos, I'll be talking much more about how we use models in testing, what is a test model, and also the concept of test design. If you want to know more about the concepts I'm talking about in the Glossary of Terms videos, it will probably help you if you take a look at the Leadership in Tests online class that I created a year or 2 ago. It covers some of the topics in more detail and obviously provides more of a structured approach to explanations of the concepts, and also gives you some idea of how to do some of the things that I talk about. I hope you can take a look at it and get value out of it. The link is below, bit.ly/leadintest.